Hello everyone. In this part of the video, we are going to uh, see the working of Qt, and we'll be using Qt Creator to create some basic code that would help us in our college assignments for OOP-CGL. So in this part, we'll cover the basics of Qt, how we can use images, and how we can draw a simple line with DDA line drawing algorithm. So first I'll create a blank Qt project with Qt Creator. So I'm assuming that you have already installed Qt Creator. So we can choose create project, and uh, we can also use Qt for Python here, but we'll be using C++. So probably you can use it for some other project, and we'll name it lesson 1. If you're on Linux, then this may change to QMake, but as I'm using Windows, we'll keep it CMake. We can rename the class, but it's optional, so we'll keep it main member. And next, make sure this kit is installed in your Qt version. Okay, so before starting any assignment, uh, we first need some area on the screen where we can draw a line or a fractal for the assignments, or even any shape. So first we need to define some finite area that has some fixed width and fixed height where we can perform all our drawing operations. So we head to main window.ui. So .ui files would define the user interface of the Qt application. So this is the main screen that will observe when the program runs. So we need some drawing area on this screen here. So uh, if imagine that I have to draw something. So first I would need a paper on which I can draw, and then I would simply insert that paper into a photo frame so that I can show it to others. So first we need to set up a frame in which our image will be rendered. So in order to build that frame, we will use label, drag and drop it here, and we can set the x coordinate of this component. Text label is basically a view component. So as you can see, we have push button, list, and group, scroll, and many other widgets. So we'll set its x to 0, y to 0, and its width, the width of the frame, to 500. You can actually choose anything here, but in most of our assignments we have taken it as 500, so I'll do the same. Yeah. And we'll rename it here. So label is the ID of this particular component. So Qt needs some identifier to determine the exact component on which you are working. So I'll label it as frame. The object name also changes here. So one thing that we should remember is that whenever we are changing the .ui file, we need to build our project. By building our project, Qt will parse this .ui file and extract all the components that we have added. So recently we have only added this one, QLabel, and this component will be then accessible in source code files, that is main window.cpp files. So we have built our project, and now we can use this frame in our code to insert some particular image that we wish to view on the screen. So just for now, just imagine that this is a frame, a simple photo frame that we have. Oops. So we'll now have a look at the file structure of a typical Qt project. So header files allow general concept in C-based programming languages. Basically, header files store declarations of functions and classes, and source files uh, they contain definitions of the respective functions and classes. So if we observe, main window.h contains a class declaration. This is the class. You can simply ignore all of this namespace declarations, and this is a constructor and this is a destructor. Now the definition of this class is provided in main window.cpp. So as you can see, with the help of scope resolution operator, we have defined the constructor as well as the destructor by including it here. This line is important. So if we wish to create any new function in our program, we first need to create a declaration here in the header file, and then we need to define it in main window.cpp. And main.cpp is absolutely useless in our case. I don't know if it's used somewhere else, but for our assignments we never need to change this file, this particular file, so we can simply ignore it. Okay, so first we have our frame ready. Now we need a canvas on which I can draw something. So as far as our assignments are concerned, we use QImage. Now this class hails from the Qt library. This is the class. I'll create an object named image, and I need to initialize this object here. So I'll call the constructor like this is the simple C++ syntax of a constructor. If you'll see here, 1 of 11. So basically I can initialize this object in 11 different ways, like this one, with different arguments. We call this constructor overloading. So we will be using this one, width, height, and format. So basically I am defining the width, height, and the format of my drawing sheet. Now you need to understand that frame, like the drawing sheet and the frame, are two different concepts. We will be drawing everything on the image, and we will finally set this image into the frame that we have created in the .ui file. So and also we need to make sure that the size of the image and the photo frame match. If the image size is greater than the frame size, then we'll only see some cropped portion of the image, and if it's small, we will get some weird boundaries. So as the dimensions of our frame are 500 500, we'll make sure that this image is also 500 cross 500. The third parameter is the format. So basically, if you know something about image processing, computers store images as matrices. So each image has three channels, R, G, and B, R, red, green, and blue. And we also have an additional fourth channel called A. A represents alpha channel. Basically, it determines the transparency or the opacity of the image. So we'll be using the RGB 888 format here. Each format has some different meaning in terms of hardware, but again, in most of our assignments, this format is relevant. So we have created a canvas here for drawing. These are just analogies. There's no such term in Qt terminology, but for our understanding, we can treat it as a canvas. So we have set up a canvas here, and now I wish to draw something on this image. So let's start by drawing a simple line here. So first, I need to define a method by which I can draw a line. So the first step is to declare a method. For declaring methods, we head on to main window.h, the header file, and I would simply declare a method. I hope you know the difference between declarations and definitions. So I would simply write void draw line DDA, draw line with the DDA algorithm, and the four coordinates int x1, integer x2, y1, integer x2, and integer y2. So we have declared this method here. We can now define this method in main window.cpp somewhere here. So I'll write main window.cpp, main window. Then I'll use a scope resolution operator. The job of the scope resolution operator is to determine from which scope is this function being called. Now this particular function, draw line DDA, could exist in multiple namespaces or even in multiple header files. So I need to tell C++ from which class I am calling this method. So basically it resolves the scope and it determines the scope, in other words. So basically I am calling draw DDA line function from main windows scope. So yeah, and we also need to add a return type here. Make sure that the function signature matches with that in the header file. So I'll now be pasting the code for the DDA line algorithm. Every one of us knows it, so I'll simply paste it here. Yeah, and before that, it is good for us to create another method that would plot one particular point on the screen. So basically, if I'm having my canvas, that is the image, I would like to draw, not draw, I would just plot one point on my canvas, because the algorithms that we have studied till now, they all work on the pixel level. Like we plot pixels continuously if we consider resonance algorithm, DDA algorithm. So it would be good for us to create a method that could plot points on this image. So we'll first create that. So again we head on header file and we declare another method here, void plot point x and y. So basically I wish to plot or draw, yeah, we can even use draw a particular point on the screen with coordinates x, y. Yeah. So we have our drawing sheet or canvas as image, and we are now going to plot a point on this canvas. So Qt has a function named image.setPixel, and basically it needs integer x, y, and a RGB value, basically the color of the point that would define the color of the point. So we can simply pass x, y, which are the parameters here, and we can define some color with QRGB. This is a built-in function from Qt which helps us define the color. So it takes three arguments, the R component, G component, and the B component. So for now we'll keep it pure red, so that stands for 255, 0, 0. So there's no component of G and B here. Okay, so we have a method that could plot a point on this image. We are only working on the image now. We have done nothing with the frame now currently. So what we generally do is we draw everything on the drawing sheet, and once our drawing is ready, we'll simply insert it into the frame. So we'll follow this process and I'll show that step for you. So yeah, so now we can paste our DDA code here. So even in the DDA algorithm, you must have seen that in the pseudocode we'll mention lines like plot point and so on. Uh, so it makes sense even in the actual code. So basically this method will plot a point of red color at coordinates x comma y on the image. So basically this is plotting a single point on the canvas. Okay, so we now have methods to draw a line on the canvas. So we wish to draw it as soon as our program starts. In the next part, we'll also see how we can draw a line when a particular button is clicked. But for this part, we wish to draw the line when our program starts. So basically, in other words, when the constructor is called. So as I said, this is the constructor. Take some space here. This is the constructor. And we wish to draw a line here on the canvas. So I'll simply call my method DDA line algorithm here and just give out some random points like 100, 100 and 200. So what we have done so far, we can actually run the program. So currently we will see nothing because we are drawing everything on the drawing sheet, but the drawing sheet is not yet inserted into the frame that we have created here. So the frame is basically empty. So that step is actually important and it leads to most of the bugs that I have seen till now. Most of my friends code. So it's important to bring that line of code here. So we have drawn a line here and now we are going to insert the canvas. Basically canvas is this image into the frame. If you don't remember, frame is a Q label which has the same width as that of the image or the canvas. Also, I'm assuming that canvas is a drawing sheet. I don't know if that's technically true. Okay, so to insert this image or the canvas or the drawing sheet into the frame, we will call UI. UI is a pointer. It is a pointer of type main window. So in order to call any function or in order to access anything from pointer, we use an arrow operator instead of a dot. So arrow, and we need to access the frame. Make sure that this, if I have named it frame 2 and then I am building the project, so frame 2 would appear here. So make sure you're building the project. I can even demonstrate yours. If I rename it to my frame, and if I try to access my frame here from the UI, it isn't available. So in other words, I need to build my project so that the file is updated. So I'll build my project here. And the build is complete. And now, okay, so we haven't changed the object name yet, so we need to even change it to, yeah, my frame. You can update it. With complete lines. Okay, so build is complete, and I hope now my frame is accessible here. So this gives us a lesson that object name is more important. So you can directly change it from here instead of going here. So you can directly change the object name. My frame. And this line of code is actually a bit complex to understand. So it's good if you can memorize it. I highly discourage it, but uh, there's no other option. Okay, I'll try to explain it in simpler terms. So we are converting our image, our drawing sheet, into a PIXMAP. PIXMAP stands for pixel map. So as you know, computers could understand images in terms of pixels. Pixels are matrices, and pixels are hypothetical constructs and to uh, to construct an image. So basically, we are converting an image to a PIXMAP, and we are setting that PIXMAP into a photo frame, which is my frame. So it actually does not make much sense here, but this is the way we have been taught. And yeah, so PIXMAP is basically uh, a map of, you can consider it as a map of pixels or as a matrix of pixels. Yeah, so we have now inserted our image into the frame, and now we can actually see the line in a up. So as you can see, the line has been drawn here. So first, I'll get a quick summary for you. So first, we defined a canvas, a drawing sheet on which we are drawing all our lines, shapes, and whatever is going to come away. And we are defining a method by which we can plot a single point on this canvas using the set pixel method. And then we have written the usual algorithm for DDA, and we are calling this method here in the constructor because we wish to draw the line when our program starts. In the next part, we'll see how we can draw this line on a button click. So we are drawing this line here, and now at till this point, we have completed all our drawing, and the step that remains is to insert this image into the frame, and we are performing that action here, which gives us the final output. Now we can merge multiple DDA calls and build a rectangle. If I insert more 3 DDAs here, I could easily construct a triangle. And if I can write a similar code for Bresenham's algorithm, I can even draw a circle here. So that was all about the basics. My job was to deliver the analogy between the canvas and the photo frame. So canvas represents or resembles the image, Q image in Qt, and the photo frame resembles the Q label that we have used in the .ui file. If you can understand this analogy better and the basic workflow, which states that first draw everything on the canvas and then insert that canvas into the frame, that is the Q label. So if you can understand this basic workflow, we are good to go for all other assignments because this forms the core of nearly all Qt assignments. In the next assignments like scanline and line clipping algorithms, we are basically uh, we are just applying algorithms. There's no change in the basics of Qt. In the next part, I'll show you how we can draw this line on a button click, and I think that would basically end the basics of Qt. So I hope you were able to understand this. You were able to understand Qt better, and thanks a lot.